Dear students, now we will move on to the organic part. That is, the last functional group organic compound as per the PU2 is concerned. That is, the organic compounds containing the nitrogen. Okay? As if in the class 11th, we have studied only the hydrocarbons. Means the compounds which contains, are the organic compounds which contains only which and which? Hydrogen and carbon acids elements, that way is a hydrocarbon. Okay? So in the second year we are having the derivatives of hydrocarbons in the form of haloalkanes and haloarenes. Then we are having the oxygen containing organic compounds, that is organic compounds which contains preferably the oxygen. Next most preferred element after hydrogen and carbon, that is oxygen, in the form of alcohols, phenols, ethers, aldehydes, ketones and carboxylic acids. Okay? So now we left with the last, that is the organic compounds which contains the nitrogen. So we are having usually the major part of this one is found to be the amines. In addition to that, we can have the cyanides, isocyanates, nitrates or nitro compounds, usually the nitro compounds, and then the diazonium salts. Okay? But as per the PU board is concerned, we have to concentrate only on the preparation and properties or the general characteristics with respect to amines, and also the preparation and some of the chemical properties related to the diazonium salts. Okay? So that we are having according to the class 12 syllabus right now. Okay? So then how to define this particular amines are? So what amines are actually? Amines. So as if we know that this is ammonia first. Which one? Ammonia. So here, if I remove one hydrogen from this and add one organic group, R for example, what the organic group is? Maybe an aliphatic group, or it may be the aromatic group, or sometimes it may be the heterocyclic group also. Okay? So if one of the hydrogen has been replaced, therefore we are getting that in the form of RNH2. It's an amine. Suppose if two hydrogen atoms has been replaced by two organic groups, maybe an aliphatic or an aromatic, or it may be the heterocyclic group, then we are getting that in the form of RNH, R or R dash, whatever it may be. This is another type of amine here. Okay? Suppose if all the three hydrogen atoms has been replaced by three organic groups, again R may be any organic group, maybe an aliphatic or an aromatic, or sometimes it may be the heterocyclic group also. If that be the case, I can expect R, N, R, R with the lone pair of electrons. Okay? So, and these are collectively called as which one? Amines. Then how to define an amine here? How to define that one? Can I say that they are the derivatives of which one? Ammonia. What the amines are? They are the derivatives of ammonia obtained by replacing. Obtained by what? Replacing 1R, 2R, all the three hydrogen atoms by an organo group, or it may be sometimes groups. Either it may be same or different, I don't know about that. Means what these are first? They are the derivatives with respect to which one? Ammonia. Derivatives with respect to which one? Ammonia. Obtained by replacing either by one hydrogen atom or two hydrogen atom or all the three hydrogen atoms by an organo groups, or it may be sometimes a group. If that be the case, it is called as which one? The amines. Means what amines are usually? They are the derivatives with respect to which one? The ammonia. Okay. So here Now we will have the classification related to this one. That is, these will have the characteristics order of fishy order. Usually amines will have the what? Characteristic order in the form of which one? The fishy order. Usually these nitrogen components that has been present usually in the form of a biomolecules, preferably the nucleic acids, some of the proteins, okay, some of the vitamins also we are having. So that is, all these are major concerned with respect to the biochemical substances. But apart from that, we are having the organic nature, even though it is bound to be the not biochemical compound, it may be some synthetically prepared also. Okay. So here, the classification or types. Classification of which one? Amines. Classification of which one? Amines. So here first is based on the nature of organogroups. Based on the which one? Nature of which one? Organogroups. They can be classified as aliphatic amines, then aromatic amines, and then the third one is the heterocyclic amines. Heterocyclic amines. So this definition is very simple here. There are also the derivatives with respect to which one? Ammonia, obtained by replacing one or two or all the three hydrogen atoms by which group? An aliphatic groups, then it is called as aliphatic amines. The same derivatives of ammonia obtained by replacing one or two or all the three hydrogen atoms with respect to are by the aryl or aromatic group, then it is found to be the aromatic amines. Suppose if it is a derivative of the same ammonia obtained by replacing with a heterocyclic group, then it is found to be the which one? The heterocyclic group is considered to be the which one? The heterocyclic amines. Okay, but as far the syllabus is concerned, we have to concentrate morely with respect to which one? The aliphatic and then aromatic. So again, these are further classified into alkyl amines, alkenyl amines, and then alkynyl amines. What they are? Alkyl or alkenyl, or it may be the alkynyl amines. Again, they are the derivatives of ammonia obtained by replacing the hydrogen atom or hydrogen atoms by an alkyl group, saturated preferably. It is called as the alkyl amines. If it is replaced, hydrogen atoms has been replaced by an alkenyl group, then it is found to be the alkenyl amines. If it is found to be the alkenyl group has to be replaced, then it is found to be the alkyl amines. So you have to know the formula for that. CnH2n plus 1 is called as alkyl group. CnH2n minus 1 refers to alkenyl group. Whereas CnH2n minus 3 refers to alkynyl group. Alkyl, alkenyl, or it may be which one? The alkynyl groups. And just it has to be replaced by which one? The hydrogen atom has been replaced by those groups, that is in the form of either the alkyl or alkenyl, or it may be the alkynyl, then it refers to the which one? The alkyl amines, alkenyl amines, and then the alkynyl amines. So here, this has been further classified as aryl amines, and then the R-alkyl amines. So we'll have the example related to this. Okay, the example with respect to alkyl amine is, for example, CH3 CH2 NH2, CH2 double bond CH single bond NH2, CH triple bond C NH2. What these are? Alkyl amine, alkenyl amine, and then the alkyl amine. Sorry, alkynyl amine. This is called as ethyl group. This is called as vinyl group, and this is called acetylenyl group. Therefore, the name of this one is called. We'll move in deep when we are discussing the nomenclature. So here it is, vinylamine. So this is called as acetylenylamine Which one? Acetylenyl amine. They are the examples, they are all the examples was related to which one? Aliphatic amines. In particular, ethylamine is an example for an alkyl amine, vinyl amine is an example for an alkenyl amine, whereas acetylenyl amine is an example for a, which one? Alkynyl amine. Now, this is the aryl amine and this is R-alkyl amine. Means both are the derivatives of ammonia obtained by replacing an hydrogen atom or hydrogen atoms by. Aryl group is called as aryl amines, R-alkyl group then it is called as R-alkyl amines. What's the meaning of aryl and then R-alkyl here? If the amino group is attached to the which one? If amino group is attached to the which one? Directly to the benzene or the aromatic nucleus, then it is called as aryl amines. If the same amino group or amino group whether it is attached to the side chain of the benzene or the aromatic nucleus, then it is called as R-alkyl amines. So this is called as phenylamine, called as aniline. So this is called as benzylamine. What amine it is? Benzylamine. That makes a difference here. The thing is, the NH2 is directly attached to the aromatic or it may be the benzene nucleus, that is why it is called as arylamide. The same NH2 group is not directly attached to that, but it is attached to where? The side chain of the aromatic ring or it may be the benzene nucleus, then it is called as the R-alkyl amine. The example related to that one is found to be the which one? Benzyl amine. Okay, so that is about the aromatic amines. So here it doesn't have the general formula like this. This is called as proline, I think. An example for an amino acid or amino acid usually it is called as, but we can't have the more constant. Sorry, proline means it is where I am COH also. Okay, it is not much concentrating with respect to that. Okay, or you can take the pyridine. Pyridine is an example for a pyridine, pyrimidine. They are the examples related to which one? The heterocyclic amines. But as far this is concerned, we can't have the more concentration with respect to this. Okay, we will majorly concentrate on either the which or which the aliphatic amines or it may be the aromatic amines. Here it is based on the which groups? Nature of the organo group. If the organic group is aliphatic in nature, it is aliphatic amines. If it is found to be the aromatic in nature, then it is found to be the aromatic amines. If that particular aliphatic groups, we can have the three types called as alkyl, alkenyl and then the alkenyl. If the hydrogen atom of the ammonia has been replaced by alkyl group, then it is called as alkyl amines. If the hydrogen atom of the ammonia is replaced by alkenyl group, then it is called as alkenyl amine. Whereas the hydrogen atom of the ammonia is replaced by alkynyl group, then it is called as alkyl amines. Suppose if it is an aromatic amines or the derivative of ammonia where the NH2 group, if it is directly attached to the benzene or the aromatic nucleus, then it is called as aryl amines. If the same NH2 group if it is attached to the side chain of the aromatic or the benzene nucleus, then it is called as R-alkyl amine. So that is the first category. We are calling that as which one? The classification based on the nature of the which group? Organo groups. Okay. Let's have the second classification. The second classification is based on the nature of a functional group or indirectly the number of hydrogen atoms that has been replaced. We will classify that under three different categories called as primary amines, secondary amines and then the tertiary amines. Primary amines, secondary amines and then the third one is tertiary amines. Tertiary amines, 3 to the power of 0 degree. Okay, so here it is based on the which one? Nature of the functional group. The amines which are characterized by NH2 called as amino as its functional group, then it is called as primary amines. The amines in which it is characterized by imino group as its functional group, then it is called as secondary amines. The amines which is characterized by tertiary nitrogen atom as its functional group, then it is called as tertiary amines. This is one demonstration. But here, the derivatives of ammonia obtained by replacing only one hydrogen atom by an organic group, then it is called as primary amines. The amines in which the derivatives of ammonia in which two hydrogen atoms has been replaced by two organic groups, then it is called as secondary amines. The same derivatives of ammonia obtained by replacing all the three hydrogen atoms by three organic groups, then it is called as tertiary amines. That is the second definition. So that is, we know that NH3 is what? Ammonia. If one hydrogen atom replaced means it is RNH2. What's that? RNH2. Means one of the hydrogen atoms has been replaced here. RNH, R dash, or I can write in the form of R2NH also. Okay? Means here, these are all the derivatives of ammonia obtained by replacing how many hydrogen atoms? Two hydrogen atoms by two organic groups. They may be same or different, that is called as secondary amines. So here secondary amines are characterized by a new functional group that is called as imino group. NH is called as what? Imino group, whereas NH2 is called as amino group. Amino is primary functional group, whereas imino is a secondary functional group amine. And then all the three hydrogen atoms has been replaced by R3N, then it is called as tertiary amines. Means all the three hydrogen atoms has been replaced by three organic group or groups, then it is called as the tertiary amines. So here, this is particularly called as a tertiary nitrogen atom as its functional group. The simple definition is amines which are characterized by amino as its functional group, NH2 as its functional group, then it is called as primary amines. The amines which are characterized by imino as its functional group, then it is called as, what is imino group here? NH is called as imino group, then it is why it is called secondary amines. The amines which are characterized by tertiary nitrogen atom as its functional group, then it is called as tertiary amines. Or you can have the extension definition. What is that? The derivatives of ammonia which is obtained by replacing only one hydrogen atom by one organic group, then it is called as primary amines. The derivatives of ammonia obtained by replacing two hydrogen atoms by two organic groups, then it is called as secondary amines. The same derivatives of ammonia obtained by replacing all the three hydrogen atoms by three organic groups, then it is called as the tertiary amines. Means they are having a special functional groups in the form of which one? The amino, imino, and then the tertiary which atom? Nitrogen atom. So the very simplest example, CH3NH2, CH3NHC2H5, CH3N, CH3, CH3. We discuss the nomenclature later, okay? Means this is just only the amino group, therefore it is called as primary amine. This is called as imino group, therefore it is called secondary amines. It is called as tertiary nitrogen atom, hence it is called as tertiary amines. Okay? The third classification is based on the symmetricity. We can classify that as simple, or it is also called as symmetrical amines. Then second one is mixed, or it is also called as unsymmetrical amines. Here refers to here amines. But this is applicable only for secondary and tertiary amines. This is not applicable for the primary amines. Applicable only for the which one? The secondary as well as tertiary amines. RNHR, RNR. This is primary, simple amines. This is RNHR dash, RNR dash, R double dash. What makes the difference here? So this is simple or symmetrical amine. This is unsymmetrical or mixed amines. They are the derivatives of ammonia obtained by replacing either the two or the three hydrogen atoms by 2 or 3 same organogroups refers to simple amines. If it is found to be the different organogroups, then it is an example for a mixed or it becomes unsymmetrical amines. For example, CH3, CH3, CH3 with N is considered the simple amine. Why? Because it is surrounded by same which groups? Organogroups. Here it is CH3, here it is CH5. Means the organogroup is found to be the different, that is why it is found to be the mixed or it becomes what? Totally the unsymmetrical. Means it is strictly applicable only for the secondary amines as well as the tertiary amines, but not for the primary amines. Okay. So this is how we are going to classify the which one? The amines under 3 different categories. The first one is based on the which one? The nature of the functional group, nature of the organogroup, nature of the which one? Organogroups. Means all those are the derivatives with respect to ammonia. If it is replaced by or the hydrogen atoms has been replaced by what? An aliphatic group. That aliphatic group may be in the form of an alkyl group or an alkenyl group, or it may be an alkynyl group, then it is referred to the aliphatic amines. Same derivatives of ammonia obtained by replacing the hydrogen atom or hydrogen atoms by aromatic group. What aromatic group? Maybe it may be the aryl group or it may be the R-alkyl group. What is the difference here? If the amino group is attached to the or amine group is attached to the which one? Directly to the benzene or aromatic nucleus, then it is called aryl amines. If the same amino as a functional group is, if it is attached to the which one? The side chain of the, which one? Side chain of the what? The benzene or aromatic nucleus, and it is called as all-alkyl amines. So that is the first classification based on the nature of the which group? Organogroups. Okay. So next, second one is based on the which one? Nature of the functional group that has been present, or indirectly the number of which atoms? Hydrogen atoms. All these three will have the replacement of hydrogen atoms by an organic groups. What is the difference here? If only one hydrogen atom has been replaced by one organic group, then it is called as primary amine. If two hydrogen atoms of ammonia has been replaced by two organic groups, then it is called as secondary amines. If all the three hydrogen atoms has been replaced by three organic group, then it refers to the tertiary amines. In particular, the very simplest definition is the amines which are characterized by amino, means NH2 as its functional group, then it is called as the primary amines. The same amines which are characterized by imino, means NH as its functional group, then it is called as secondary amines. The same amines in which are characterized by tertiary nitrogen atom as its functional group, then it is called as the tertiary amines. Means we are having three different functional groups with respect to the amines concept. NH2 is called as amino, NH is called as imino, N is simply called as a tertiary nitrogen atom. Next, the third classification is based on the symmetricity of the given amines. We can classify that as either the simple amines or it may be the mixed amines. Simple amines are also called as what? Symmetrical amines, and mixed amines are also called as unsymmetrical. What's the meaning of that one? But here the condition is it is restricted only for the secondary and then the tertiary amines, but not for the primary. Okay. So here both are the derivatives of which one? Ammonia, in which 2 or 3 hydrogen atoms has been replaced by 2 or 3 same organogroups, means it is called as simple or symmetrical amines. 2 or 3 hydrogen atoms has been replaced by 2 or 3 different organogroup, then it refers to the which one? Mixed, or it is also called as unsymmetrical which one? The amines. Okay. So that is about the definition and then the classification related to the which one? The amines. Okay. Next we will have the amines having the Lewis character first, and also it is having a distorted structure with respect to the tetrahedral, means usually it is a pyramidal structure, and that is indirectly the distortion with respect to which one? So here usually amines will have the pyramidal structure approximately. That pyramidal structure depends upon the nature of the which one? Organogroups. As if we have discussed in the previous chemical bonding and molecular structure in the class 11th, I think, the nitrogen atom in ammonia is found to be what? Hybridized. sp3 hybridized. sp3 hybridized. Here, this is expecting the tetrahedral geometry with a bond angle of 109 degree 28 minutes. 109 degree 28 minutes. But here it is not possible. Why? According to the VSEPR theory, what's that theory here? Valence shell electron pair repulsion theory. This is called a lone pair, this is called as bond pair, this is also called as bond pair, this is also called as bond pair. As if among the 4 valence shell electron pairs, 1 is the lone pair called as a non-bonding pair and 3 are bonding pairs. According to the VSEPR theory, what we have decided, the lone pair repulsion is far greater compared to that of lone pair with the bond pair repulsion followed by the bond pair with the bond pair. So this is called as bond pair repulsion, this is called as bond pair repulsion, but this is lone pair bond pair repulsion, this is also called as lone pair bond pair repulsion. Means whether all the repulsions between the 4 valence shell electron pairs are found to be same or different. It is different according to the VSEPR theory. So here, this repulsion is found to be the greater compared to that of this. But this again it is found to be the more. What's the meaning of that? According to the VSEPR theory, the lone pair bond pair repulsion is far greater compared to that of the bond pair with the bond pair, such that the bond angle gets decreased from 109 degree 28 minutes to 107 degree. And then the geometry of this molecule changes from tetrahedral to which one? The pyramidal. That is why ammonia molecule is exhibiting the what? The pyramidal geometry. Suppose if I take CH3 as an organic group, it is called as a trimethylamine. It's called as what? Trimethylamine. So here the bond angle is going to be nearly 108 degree. It is also sometimes the same pyramidal structure, but it is not exactly equal to the tetrahedral, because to exhibit the tetrahedral, the bond angle is exactly how much? 109 degree 28 minutes. But here, as if the same lone pair bond pair repulsion is far greater compared to that of the which one? Bond pair with the bond pair repulsion, the bond angle gets decreased. So that decrease in the bond angle changes its geometry from tetrahedral to the what nature? The pyramidal nature. Okay. In addition to that, this which one? Amines are exhibiting the Lewis base character, and also they are found to be the which one? Nucleophiles also. They exhibit the what? Nucleophiles. Why they are nucleophiles? Means because as if they contain, say, lone pairs on the which atom? Nitrogen atom. They are found to be the electron pair donors. Electron pair donors. If it is electron pair donors, means it is found to be the what? The Lewis base. Apart from that, it is a nucleophile. Why it is called as a nucleophile? Means because nucleophile means it is nucleus loving, or it is also called as electron eating. Nucleus is positive charge. Means it is having the deficiency with respect to the which one? The electrons. That is why it is having an electron rich, means it is not having an affinity towards the electrons, but it is affinity towards the which one? Positively charged. That is why it is called as nucleophiles. In particular, they are the best examples for neutral nucleophiles. It refers to which one? The neutral nucleophiles. Why they are found to be the neutral nucleophiles here? As if we know that. What is that? If the species is found to be the rich in its electrons, they are first found to be the what? The nucleophiles. Those nucleophiles may be of two types. Either it may be the charged nucleophiles or it may be the neutrals. So here Cl minus, Cn minus, NO2 minus, they are also the nucleophiles, but they are found to be the what? Charged nucleophiles. Why? Because they are having a net negative charge on that. Means they are moving towards the which one? Positively charged. Positive charge means it is called as nucleophiles. Means it is having an affinity towards the nucleus called as positive charge, that is why they are first called as nucleophiles. If it exhibit a charge, then those are called as usually the charged nucleophiles. Therefore, as it doesn't having any charge, means the amines will have only the lone pair of electrons on that, but doesn't have any charge. That is why the best examples for which one? The neutral nucleophiles. So as if they are rich in electrons, means they can have the capacity of donating an electron pair. Therefore, electron pair donors are considered to be the what basis? The Lewis basis. Okay, so this is the geometrical nature, and then the Lewis base character, and then the nucleophilicity or nucleophilic nature with respect to the amines. Then we will discuss after the preparation, and after the preparation we will have the chemical properties, why the basic nature of amines is due to extensive. Means it is not only a Lewis base, but also it is an example for a Lorry-Bronsted base, and also it is having the solvation effect. Okay, so these three conclude to get the exact relative basic character of three different types of amines called as primary amines, secondary amines, and then the tertiary amines, followed by among the aliphatic amines and aromatic amines, which is found to be the more basic. Okay, so that all we will discuss on the concept of Lewis base character, Lorry-Bronsted character, and then the hydration effect in the form of usually the solvation. In particular, it is called as hydration effect, followed by sometimes it may be the steric hindrance also. Okay, so that all we will discuss in the next session of this particular after the preparation of the various types of which one? The amines. Okay, now so next is about the geometrical nature based on the nature of which one? Hybridization. Next we will move on to the nomenclature of, or how to name these particular amines in both the common system as well as the IPS system. Again we have to classify that as how to name the alkyl amines, how to name the alkyl amines, and then how to name the which one? Alkyl amines. And in case of the aromatic substances, we can have either in the form of aryl amines and then the R-alkyl amines. Okay, so that all the nomenclature not only in the common system but also in the IPS system, that we will discuss in the second session of this particular chapter, that is called as amines. Okay, so thank you.